Hi, my name is Yasser Al-Mashad. I work for F5 as a security solution architect. In this video, we will walk through the GitOps process of publishing Kubernetes applications and services to the public internet while ensuring the security and access control at the same time, all in automated fashion utilizing the continuous delivery tools and methods. I have prepared a demo environment that includes all the required components to demonstrate the process from end to end. So let's start by having a look at the environment blueprint. I will explain each component individually, then I'll explain the flow of this demo. EKS cluster is a managed Kubernetes cluster by AWS. Inside this cluster, we have a demo application deployed already, but it's not published yet. The Ingress controller from NGINX, it has two parts. The first part is the traffic management part. This takes care of publishing the application, manage the routing to the application, doing the load balancing, the session persistence, health monitoring, traffic splitting, etc. The second part is the security, which is also built inside the Ingress controller. And this includes several security policies like web application firewalling policies, authentication policies using OpenID Connect and job tokens, rate limiting and DDoS protections policy. We will configure the Ingress controller to export the events and the violations to Grafana. And we have also created a custom dashboard in Grafana that will visualize those security events. The NLB is a layer 4 load balancer. I'm using AWS CLB or classic load balancer here. Its job is to publish the NGINX Ingress controller to the internet. Flux is a continuous delivery component. It will continuously sync with the GitHub and apply that to the Kubernetes cluster. Basically, it marks GitHub as a desired state. And as soon as it detects any changes or new objects committed to GitHub, it will sync them and then it will apply them to the Kubernetes cluster. The OPA Gatekeeper is a security component. It works as an admission controller. Its job is to filter the objects and the resources that retrieved by Flux from GitHub and either allow or deny them as per the security policy. Since GitHub is the source of the truth, so we want to have some control in which kind of objects and resources that people commit before we apply them to Kubernetes cluster. In this demo, I have configured the OPA Gatekeeper to only allow the objects which are related to publishing the applications. Of course, we can go more granular and enforce role-based access control. The external DNS component is its job is to automate the DNS records creation. So as soon it detects, it first watch all the Ingress resources and the virtual server resources. And as soon as it detects a new resource applied, it will extract the host name value and it will create a DNS record with that host name in the DNS zone, which is hosted by Route 53. Weave work is front end and the dashboard for Flux. So we will use it to see Flux in action and we can see the synchronization events. So the flow will be as following. I will log into GitHub as a platform engineer or the cluster admin, and then I will create the Ingress controller objects, which are the policies and the virtual server that reference those policies and the published application. And I will commit that. As soon as I commit it in GitHub, Flux will detect that and it will sync these new objects. And then before apply them, it will send them to OPA Gatekeeper for inspection. And if OPA approve, then this will be applied to the Ingress controller to publish the application. At the same time, ExternalDNS will detect the new virtual server applied. It will extract the host name and it will create the DNS record. And once the DNS record created, then the users can use it to access the application. So with that, let's jump to the demo. So this is the GitHub that I'm gonna commit the policies and the virtual server resource. And this is the Weave GitOps dashboard that we can monitor the Flux syncs and we can also force the sync instead of waiting for the interval. And this is my DNS zone, which is route 53. So we expect the DNS records will be created here, and this will be Grafana dashboard. All right, so let's look at what we actually gonna commit in the GitHub. So first we have an app protect policy. This is the web application firewall policy. It's example app protect policy. And the next is the Ingress controller policy, which reference the app protect policy that I just created, and also the logging settings, which will export the events to the Grafana dashboard. And then we have the virtual server object, which will go into publish my application. This is the host name. So this host name it will be detected by the external DNS, and we will create a record for it. So currently this host name does not exist. If I go to my CLI and try, for example, to dig for this host name, it doesn't exist. And if I try to dig also publicly, obviously also it does not exist yet. All right. We will also watch the external DNS service from here. So I'm gonna log, yes, external DNS service, which is deployed in Kubernetes. And as you might see, I have configured it to sync every 10 seconds. All right. And we can check that the Kubernetes object for virtual server, for example, I have only one exist already, app protect policy, or let's say just policy. And it's just a couple of policies. So now let's commit. So now let's commit the policy and the virtual server. I'm gonna just push them to my GitHub. They are pushed already. So if I just refresh my GitHub repo, I should see that the WAF policy and the virtual server. Now let's go to the with GitOps to see if Flux actually detected that change in the GitHub and created the resources. And indeed, I can see that those were created already. If I go back to my Kubernetes cluster, I can see now there should be new policies applied already here. Yes, and there should be a new virtual server that's already here. And if we look at the watch the external DNS service, we can also see that the external DNS detected the virtual server creation, and it's able to extract the host name and created a record for it. Right. So if we go to validate that with route 52, we should see a record here for that. All right. I know that the record is created. Probably I need to relog into. Okay. So just to save some time, I will open my browser and I will access that because I know it should be already created. And indeed, it was already created. And once this, so it's opened again. Let me go to route 53, and we should be able to see the record already there. And yes, indeed, the record was created and I'm able to access it, as you can see here. And this application is also protected. So if I try to launch an attack against it, let's say just to try to simulate a cross-site scripting attack. This attack should be also blocked. And we can also verify this from the Grafana dashboard. So if we go to my Grafana main dashboard for NGINX App Protect, we should be able to see that this dashboard is already created here. The violations from previous and also the current policy, which is this example policy, and I should be able to see the individual logs here. So this is the one that I just launched right now, and if I click on the support ID, that can also take me to more details about the violation itself. All right. So this is it. Let's try to publish one more service and see how long it takes end to end. So I will say publish example 100, the same settings. Let's commit that. Let's force the sync to happen by Flux. And let's see how long it takes. So it says it's configured. Let's check the external DNS. And you can see how quick is it, right? If I take this new host name, and if I try to access it, I can see that my application is published also publicly. All right, so the last thing I want to show you, which is the OPA Gatekeeper in action. So OPA Gatekeeper will basically control what is allowed and what is not. In this demo, I have restricted all the resources to be only NGINX resource. If I try to create any resource on GitHub, so let me try to create a new file. I will try to create an object, let's say deployment to object. Let me generate the YAML file quickly. So I'll say kubectl create deployment. Yeah, let's do a dry run, just generate this YAML file, take these resources, paste it here, and I'll say commit that. And let's go to with GitOps and try to sync. I expect OPA Gatekeeper should block this. And indeed, you can see this was forbidden, and they say that you are denied, the resource is not allowed. And with that, this concludes my demo. Thank you for watching.